18.4 Glacial deposits. Distinguish between the two basic types of glacial drift. List and describe the major depositional features associated with glacial landscapes. A glacier picks up and transports a huge load of rock debris as it slowly advances across the land. Ultimately, when the ice melts, these materials are deposited. In regions where glacial sediment is deposited, it can play a significant role in forming the physical landscape. For example, in many areas once covered by the continental ice sheets of the recent ice age, the bedrock is rarely exposed because glacial deposits that are tens or even hundreds of meters thick completely mantle the terrain. The general effect of these deposits is to reduce the local relief and thus level the topography. Indeed, rural country scenes that are familiar to many of us, rocky pastures in New England, wheat fields in the Dakotas, rolling farmland in the Midwest, result directly from glacial deposition. Glacial drift. Long before the theory of an extensive ice age was ever proposed, much of the soil and rock debris covering portions of Europe was recognized as having come from somewhere else. At the time, these foreign materials were believed to have been drifted into their present positions by floating ice during an ancient flood. As a consequence, the term drift was applied to the sediment. Although rooted in an incorrect concept, this term was so well established by the time the true glacial origin of the debris became widely recognized that it remained part of the basic glacial vocabulary. Today, glacial drift is an all-embracing term for sediments of glacial origin, no matter how, where, or in what shape they were deposited. Geologists divide glacial drift into two distinct types: 1. Materials deposited directly by the glacier, which are known as till, and 2. Sediments laid down by glacial meltwater, called stratified drift. Glacial till. As glacial ice melts and drops its load of rock fragments, till is deposited. Unlike moving water and wind, ice cannot sort the sediment it carries. Therefore, deposits of till are characteristically unsorted mixtures of many particle sizes, figure 18.23. A close examination of the sediment shows that many of the pieces are scratched and polished as a result of being dragged along by the glacier. Such pieces help distinguish till from other deposits that are a mixture of different sediment sizes, such as material from a debris flow or a rock slide. Figure 18.23 Glacial till. Unlike sediment deposited by running water and wind, material deposited directly by a glacier is not sorted. Figure 18.15 provides an example of till being deposited at the terminus of a glacier. Top photo by Michael Collier, bottom photo by E.J. Tarbuck. Boulders found in the till or lying free on the surface are called glacial erratics if they are different from the bedrock below, figure 18.24. Of course, this means that they must have been derived from a source outside the area where they are found. Although the source for most erratics is unknown, the origin of some can be determined. In many cases, boulders were transported as far as 500 kilometers, 300 miles, from their source area and, in a few instances, more than 1,000 kilometers, 600 miles. Therefore, by studying glacial erratics as well as the mineral composition of the remaining till, geologists are sometimes able to trace the path of a lobe of ice. Figure 18.24 Glacial Erratic. This large glacially transported boulder, called Dome Rock, is a prominent feature near Nauset Bay on Cape Cod. Such boulders are called glacial erratics. Photo by Michael Collier. In portions of New England and other areas, erratics dot pastures and farm fields. In fact, in some places, these large rocks were cleared from fields and piled to make fences and walls. Keeping the fields clear, however, is an ongoing chore because each spring, newly exposed erratics appear. Wintertime frost heaving lifts them to the surface. Stratified drift. As the name implies, stratified drift is sorted according to the size and weight of the particles. Ice is not capable of sorting sediment the way running water can. Therefore, stratified drift is not deposited directly by the glacier the way till is, but instead reflects the sorting action of glacial meltwater. Some deposits of stratified drift are made by streams issuing directly from the glacier. Other stratified deposits involve sediment that was originally laid down as till and later picked up, transported, and redeposited by meltwater beyond the margin of the ice. Accumulations of stratified drift often consist largely of sand and gravel because the meltwater is not capable of moving larger material and because the finer rock flour remains suspended and is commonly carried far from the glacier. Evidence that stratified drift consists primarily of sand and gravel can be seen in many areas where these deposits are actively mined as aggregate for road work and other construction projects. Landforms made of till. Perhaps the most widespread features created by glacial deposition are moraines, which are simply layers or ridges of till. Several types of moraines are identified, some are common in mountain valleys, and others are associated with areas affected by either ice sheets or valley glaciers. Lateral and medial moraines fall in the first category, whereas end moraines and ground moraines are in the second. Lateral and medial moraines. Alpine glaciers produce two types of moraines that occur exclusively in mountain valleys. The first of these is called a lateral moraine. As discussed earlier, when an alpine glacier moves down a valley, the ice erodes the sides of the valley with great efficiency. In addition, large quantities of debris are added to the glacier's surface as rubble falls or slides from higher up on the valley walls and collects on the margins of the moving ice. When the ice eventually melts, this accumulation of debris is dropped next to the valley walls. These ridges of till paralleling the sides of the valley constitute the lateral moraines. The second type of moraine that is unique to alpine glaciers is the medial moraine, figure 18.25. Medial moraines are created when two alpine glaciers coalesce to form a single ice stream. The till that was once carried along the sides of each glacier joins to form a single dark stripe of debris within the newly enlarged glacier. The sketch in figure 18.25 illustrates this nicely. The creation of these dark stripes within the ice stream is one obvious proof that glacial ice moves because the moraine could not form if the ice did not flow down valley. It is common to see several medial moraines within a single large alpine glacier because a streak will form whenever a tributary glacier joins the main valley glacier. Smart figure 18.25 formation of a medial moraine. Kennecott Glacier is a 43-kilometer, 27-mile, long valley glacier that is sculpting the mountains in Alaska's Wrangell, St. Elias National Park. The dark stripes of sediment are medial moraines. Photo by Michael Collier. Mobile field trip. The Glaciers of Alaska.